webinar, How to Use GNSS Innovations to Optimize Your Surveying Field Workflows. I'm Christine Grail with Leica Geosystems, and I'll be your moderator for today's session. Our presenter today is Bob Kilburn. Bob has a surveying background that encompasses many roles, both in the field and office. He began his career as a Marine Field Artillery forward observer, then spent some time as a rodman and crew chief before moving into technology support and training for surveying equipment and software. Bob served as the Leica Geosystems survey sales and support representative in Wisconsin for the last 5 years and has recently taken on the role of product manager for the US and Canada. In this capacity, he's focused on listening to your ideas, needs, and challenges to help find solutions that make your job easier and more productive. Also on the line with us today, we have Pierre Lebay, Ted Miller, Burke Asay, and Tim Kerr from Leica Geosystems, who will be answering your questions behind the scenes. We will also have a Q&A with Bob following the presentation. I do encourage you to ask questions throughout today's session. Simply type your questions into the questions box that you should see on your screen. Depending on the number of questions, we might run 15 to 20 minutes past the top of the hour today. If we are unable to get to all of your questions in today's session, someone will reach out to you after the webinar by email. Now, since the introduction of civil GPS nearly 40 years ago, the technology's had a huge impact on the surveying profession. The expansion of the global satellite system, which we now refer to as GNSS, along with ongoing technology developments, have made the GNSS rover one of the most valuable tools in a surveyor's toolbox for its ability to quickly cover large areas while providing accurate real-time positioning. But as with any technology, the speed of innovation doesn't necessarily equal the level of adoption. Surveyors who are comfortable with proven technologies don't always rush to implement the latest advances. And with the almost warp speed of technology innovation within the last several years, even surveyors who do make regular investments to stay on the leading edge don't always fully understand the power and potential of the systems they use. To further complicate the situation, manufacturers use their own terminology to define new capabilities. For professionals who want to optimize their GNSS systems to maximize the safety, efficiency, and results of their surveys, understanding the capabilities is not always straightforward. In today's session, we're going to walk through some of the most meaningful developments in GNSS over the last several years, explain some of the terms, and help you become more knowledgeable about how you can fully leverage these functionalities to optimize your field work. For those in the audience who already use Leica Geosystems technology, please note this is not a training session. We do have training courses available that will give you a deep dive on the specific features, functions, and applications of your hardware and software. If that's something you're interested in, I encourage you to reach out to your local representative for more details. What we will do today is give you an overview of key capabilities so that you can be more informed as you use your current technology and as you look to make future investments. So with that, we'll go ahead and get started. And I think the first term that we want to talk about here that you'll see often in relation to the Leica GNSS technology is Smart Check. So Bob, can you help us understand what Smart Check is?
Yes, thank you, Christy. And Smart Check is built-in redundancy. And like you mentioned, manufacturers many times have to create terms to help define technologies or processes inside of their hardware. And Smart Check is one of those. Now, this is not new to Leica, but it's just as relevant today as when it came out probably close to 15 years ago. And what it allows us to do is when a receiver is in a high multipath environment and it has an initialization, and those that are used to using GPS are familiar with what that is, but it's when you have a fixed ambiguity of your sensor and your correction to get a position. But what the Smart Check actually does is it's constantly checking that initialization. So it's on one part or one piece of the processor, it's constantly looking anew at the satellite constellation, computing a new initialization and comparing it to the one you have. That's usually done about every 7 seconds or so. Before this technology was launched, we did things like turn our GPSs upside down so that they would lose track of all the satellites and then turn them back up. right and let it reinitialize itself. As the receivers got better and smarter, that wasn't good enough because they would continue to track satellites even though it was multipath off the ground being bounced back up to the receiver. So then there was places inside the software you would go to tell it to drop the initialization and create a new one. And Smart Check is doing this for you. So you can just simply wait the 5 or 6 or 7 seconds to get a new check that shows you that your current initialization just got verified with a new one that was computed and that you're good to go.
So we're really talking then about reliability, right?
It's absolutely that reliability, the redundancy of, and building the confidence in the solution you're getting from your hardware.
Okay, excellent. Now, something else you will often see when we're talking about Leica GNSS technology is SmartNet. Tell us what SmartNet is all about.
So SmartNet is our network correction for RTK service. So we have base and rover that many people are familiar with. A lot of people are familiar with networks, whether they be a state solution or there's other competitors that have networks as well. There's networks built strictly to service the agriculture industry. And SmartNet is the Hexagon Leica branded network for the world, but specifically we're talking about North America here. We have 1,500 stations in 50 states, so not every state is completely covered, but we are present in every state and 8 provinces in Canada. And this is not exclusive to Leica receivers, so it can be used by other brands, other makes and models of receivers. The big thing you want to know and check always is the quality of your network. There's many other networks that are very well built and maintained, and then there's other ones that, while they may be good networks for the design purpose, aka agriculture, they don't or wouldn't meet the demands and the accuracies required by a surveyor. So that's something you always want to be aware of. And having SmartNet is really about having productivity. It's about being able to go out, and as long as you have a connection to a network and you're inside of the large area you can see on the screen that's covered by SmartNet, you can just start your receiver and go to work. You can let us worry about modernization of the base stations that these corrections are being derived from, and the like. So it's just about being more productive, being able to cover this large area without changing and worry about getting new logins to get on other networks in different areas.
Okay, excellent. That makes sense. Another term that we see when we're looking at like a GNSS technology is SmartLink. What is SmartLink?
So SmartLink is XM radio for your RTK solution. So you need a real-time correction and you're working outside of maybe that SmartNet covered area, or there's not another alternate network in there, you can get a correction from a satellite-based receiver. So this is something that became available with our GS16 receiver, and some GS15s were able to be upgraded to this, and it allows you to subscribe to get a network correction. You do need to maintain that specific satellite. So many times you're going into high multipath environments, you can block many satellites, but you can track many other ones. So you're able to still calculate a position if you're using base and rover or network RTK. When you're using SmartLink, you can drop any other single satellite, but you have to maintain the connection or the visual line of sight to your SmartLink satellite that's providing that correction source. So many times plain states and stuff like that that aren't fully covered by conventional networks, this is a great solution to help them be more productive in those environments.
So again, we're talking about that productivity that's so important to today's surveyors. Our next topic is really the RTK Plus and self-learning. We hear those interchangeably together. What is RTK Plus and what are we talking about with self-learning GNSS?
So with those previous advances we were talking about with SmartNet, with the ability to use smart link, with the number of satellites that have been launched and the number of signals on each satellite multiplying rapidly, having a receiver that can make decisions basically second by second on what the best RTK or satellite geometry or what satellites to use is very important, along with maybe you step over a hill and you lose your cellular connection, being able to just transition seamlessly into using the SmartLink service or SmartLink fill service to bridge the gap, to go measure. Maybe it's just a couple of iron pipes, maybe it's just a fence on the back of a property line. It would take a lot of time and effort to go measure another way. I'd either have to set up a different base station or back up to some place where I could set some control to set up a robotic total station to make these measurements. Now I can bridge the gap. So it's another technology enhancer that allows us to bridge gaps when RTK position or accuracy is acceptable for the measurements we're making. We don't have to pull a different tool out of our toolbox to go get those measurements.
So we're really talking about efficiency here more than anything.
It's efficiency, and it's not manual. That you don't have to go in and turn off specific satellites. You don't have to go in and make these decisions. It's really about the processor speed that's built into these sensors that allows them to do it for you.
Okay, well, what about the other things that we've been talking about so far? Is there anything that the professional in the field needs to do in order to take advantage of the capabilities that we've been discussing?
Like we said, many of these, the SmartNet, SmartLink are subscription services. So those are things that you would need to talk to a local sales rep about acquiring, or maybe do some research online. Obviously, a lot of this is on Google, but you can contact your sales rep. And then some of it is your receiver and understanding the value that maybe is gained. What is the true power? Okay, you bought this receiver before. It will always perform to the level of when you acquired technology. But are there gains that will make you more productive, more efficient in the field that outweigh just replacing a sensor that is still working, but give you additional gains to your business and what you do in the solutions and the deliverables you give to your customer?
Those are great things to consider. All right, so all of those things are really significant advances on their own that we've seen over probably the last 5 years. Now we're also seeing an acceleration of GNSS technology, both in terms of what's happening in the global satellite constellation and how sensors are able to make use of this information and add a greater level of intelligence to the results. Can you talk us through what this means for surveyors in their day-to-day work? And I am going to go ahead and let you take over on the screen here in just a moment so that we can more easily share the next few slides.
Absolutely, but expanding the boundaries and taking advantage of the signals and the corrections that are provided by the satellite. So these are modernization things that have come about by the US with GPS and other countries, be it Russia with the GLONASS satellites or the European Union with the Galileo satellites. And the enhancements that are available through those services or those technologies that have been launched and put into space as part of the space component. So the next slide here, we're talking about what it would have looked like roughly in 2006, maybe with just some GPS satellites on the left there, as opposed to the current constellation using full GNSS, which includes both GLONASS, Galileo, Beidou, and the GPS signal, and all the modernizations that have come across with those. So we have things like the L5, which is not on some of the original satellites, but now the constellation is pretty robust, and 14 of the 30 satellites support the L5 signal. And 2 support the new L1C, which there's a side note, don't confuse that with the original L1CA correction, which was the original civilian signal off of the GPS signal. So this is going to make us more and more robust. It's the multi-frequency, it's the ability to work in more high multipath environments, specifically in canopy and stuff like that. Also noted on here is that GLONASS has 24 current operational satellites. Galileo has 22, and Beidou has 42. However, only 6 of those are in a global orbit. And as a side note, we'll send out a PDF of a PowerPoint that covers in great detail all the different GNSS modernizations. And this is just an attempt to save you from having to go and research each one of these and each one of their country specifications. We've kind of consolidated them to share them all at one time. So we'll be sending that out after this presentation. So this is where we get into some of our experiences and talking about specific examples and what we learned and sharing those with you. So this is an example of where we did some testing right after the GS16 came out. Probably the most popular GPS receiver that we had was the GS14 before this. And we wanted to see what the real difference was. So we started pushing the boundaries and taking it into environments. L5 was now enough satellites. We probably had 7 or 8, so we could find times of the day where we had enough L5 satellites up there to make a difference, and we could see what the results were on the ground. So you can see, like, this is a traverse that we did with manual total stations, putting some control out there, and then we went and shot those points to get comparisons or to see where we could get initializations and how the solution worked in the field. And when we were running the 2 sensors side by side, say maybe in the morning, I don't have the specific times, but we would not have enough L5 satellites, and both sensors performed very similarly. There were some differences, and the GS16 was slightly better. Maybe you'd get initialized a couple of seconds faster, but not a drastic difference. And then when you went to like point number 21, at the end there would be no way to get a measurement on that. Neither sensor would initialize. However, when we went back either in the morning or the afternoon, when we had several L5 satellites, every time we initialized much faster with the GS16 because of the L5 component that was available there, or we initialized it all and the GS14 wouldn't. So maybe 22 and 21, we would not get any initializations with the GS14, where we were able to initialize and take good measurements with the GS16. The next slide will kind of run through a scenario that was done by Pierre Lebay. And this was just some testing that we actually have a little more metadata on to help quantify the value of the L5 component. So he went into this wooded environment. This is a quick video just to give you some context of the size of the trees and the environment that he was measuring and working inside. And we were again comparing the GS14 to the GS16 just for our own knowledge and to gain some perception and value that we could help display to the customer.
Now, does this mean, Bob, that with the GS16 you can survey in the trees?
It doesn't. It means you can push boundaries. So in this case, we were able to go further than we could ever go before, and we were able to work in these environments. Now, I don't know specifically what time of year it was. Maybe there was a little more canopy off or on. There's nothing that says you'll always be able to work in every tree environment. Your length of your baseline, whether you're using base and rover, your network, very important component to this is your network or the base that you're using. Does it support full GNSS? Because if you use and many people do run mostly network rovers, for instance, they go out to an environment that doesn't have a network. So then they set up their own base, and they may be using a legacy receiver they have. Well, as soon as you use that legacy receiver that doesn't support all the signals that your rover does, the ones your rover is tracking become irrelevant. The two need can only use common sources. So if a satellite is not seen by one or the other, it can't be used. So if you take anything away from the base, you also have to end up taking that away from the rover. So while we're pushing boundaries, and one of the main tenets and rules that our developers live by is they try to make this line very, very narrow, which means that if you get initialization, your initialization is good, and you can either work or you can't work. The last thing we want to do is get bad initializations and bad measurements, right? So that's something that manufacturers can play with, how loose and how restrictive they are when they allow those initializations, and we keep ours to a very, very tight line. What we're showing on this slide is that same comparison. On the left were measurements taken with the GS14 and the initialization times. We had a max of 5 minutes to get initialized before we would move on to the next point. And you can see there, it took about 24 minutes to measure 6 of the 10 points. So only 60% of our target points were measured. And now we have to find another tool in our toolbox to go measure those. And it took us 24 minutes, as opposed to when we went to the same exact site, those same exact points with the GS16, we were able to get 90% of them in half the time. So it took about 12 minutes to take 9 of the 10 measurements, and there's only 1 point that we couldn't get. So even if we had to traverse, and let's say that it by chance the one we didn't get was 18, which is down here, if that hadn't been the one, this is great for us. We can set up on the sidewalk on the other side of the street, we can RTK some points, and we can take a total station measurement. But let's say that it was the hardest point, this 4 or 1004 back here. Even that traverse to a single leg would be much faster or easier to blaze and to get in there and take that measurement than if we had to traverse to 4 points in this type of environment. So the efficiency gain is definitely there. Even if you can't get 100%, 90 is much better than 60.
Now help us understand the time frame here. I mean, we're talking about the GS16 was introduced how many years ago?
2016 is when the GS16 was introduced.
Okay, so it's, we're looking at 4 years ago, and the GS14 obviously was the kind of the older technology at that point. So that was a pretty significant productivity gain just going from the GS14 to the GS16. And obviously, there have been advances since then.
It continues to advance, and some of those advancements, like I mentioned, the L5 component in the previous scenario we were talking about having to go out in the morning or afternoon, that'll sound familiar to people that were doing GPS in 2004, 2005, 2006, when sometimes you didn't have a constellation except for certain hours of the day. So we were going back to that. Well, now we pretty much have more than one. So there's several, with 14 of the 30 satellites supporting the L5 signal. Now you can pretty much go out anytime and you'll have multiple L5 satellites, even without a full constellation. So it's definitely doing nothing but getting better, and some of these enhancements come into space segments. So like that, the fact that Galileo took a long time, it was something that people were talking about to develop, and then all of a sudden, a couple of years ago, we went from launching single satellites with a space mission in respective countries to being able to launch 4 satellites with a single space mission. It just exponentially allowed them to grow their constellations to get to where they wanted to be, and we are the beneficiaries of that, all of the people using GNSS out there. So following on those same footsteps, a couple of years later, we launched the GS18T, which was a huge advancement for us and for everybody because it gave us a way to measure tilt compensated points without using a magnetic compass. So magnetic compasses have been an issue, which is why William Austin Burt built the first solar compass for surveyors in 1835. So we recognize that magnetic disturbances in the environment are a problem, even to a regular magnetic compass that long ago. Well, take all the technological advancements we have, the buildings, the steel in buildings, the number of cars, the underground electric, overground electric, different rate, all these things are disturbances to a magnetic compass. So with the launch of the IMU-based correction for a tilt rover, we were able to have a calibration-free magnetic immune tilt rover, and it was proven and accurate and reliable, which is all things that surveyors absolutely need to trust in a tool and to put it into service in their fleets. This wasn't just about overcoming, it's about changing what we could measure and how we could measure it. You know, being able to check, did this truck just run over this hub? If anybody's been on a construction site, you're always, did he back up and then move forward? Do I need to flag it? Do I need to dig it out and replace it? Did this backhoe just eliminate this hub? I just blue topped all this equipment moves in. I can make those checks as I walk by, and as you can see, just huge magnetic disturbances there with the gas motors and the firing and all that stuff. So these are the types of things that we were able to overcome. You know, one of the subtle challenges was forgetting about the bubble and the faster stakeout component. This was a challenge more because of our legacy training and being so used to having to level that bubble before we took a measurement, where here we knew our orientation, we know where we're going, we know what the position is. I don't have to stop, plumb the rod, move it a foot by 3/10, move the tip over there, replumb the rod, move it 1/10 by 1/10, kick it a couple of hundredths to the northwest and call it good. I can see it on my screen, my arrow goes green, I know I'm within my tolerances that I choose, and I set the point. It's probably 2 to 3 times faster staking a house or staking specific points using this tilt rover. So again, it was about efficiency to the end user, was the purpose of having this technology. It's not just a cool widget that made for good marketing. It was something that actually delivered value to the end user. And if you have more work than you can get done, if your guys are working 70 or 80 hours a week, this is technology that can allow you to alleviate some of that stress on your workforce, can allow you to take in more jobs and get them done faster so that you can increase your revenue and your profitability of your business. Our latest release, and we'll get into some scenarios and working environments of this, but is truly embracing the visual positioning. So again, now that we have a tilt rover, what happens if I could capture in images points that I can't put this rover tip on, things I can't measure with a GPS traditionally or up until this point, but GPS accuracy is an acceptable technology. So I don't need to do a closed traverse and measure these points and using another tool for an accuracy. I'm using it because the current sensor, the current technology I have doesn't give me the ability to get the measurement I need. And what this is true sensor fusion. So we've taken the GPS positioning that we've already talked about, all the technologies that go into that. We include the IMU, so now that we can compensate for the pitch, heave, and roll or know what that is of the receiver. Now we add a vision sensor or a camera to that, and the processing power to be able to fine tune the center of that and be able to pick points and actually automate many times the picking of those points to calculate points inside the images. And we'll go into that here in a second. So again, we're looking at the GNSS survey grade accuracy isn't acceptable. So here we're talking 2 to 4 centimeters two-dimensionally and 3 to 5 centimeters three-dimensionally. If we increase and use the Smart Link correction service, we increase that by a couple centimeters on both sides. What we're doing here, like I said, true sensor fusion, and what does that look like to your receiver? And this is a quick video of what that imaging sensor is doing. And anybody who's familiar with our RTC 360 knows that we have the Viz technology, which helps position the sensor. So we're positioning that laser scanner to within a couple of inches using an IMU and using the visual positioning. What we're doing here is not positioning the sensor. We know very precisely where that center is because we have an RTK initialization and we have an initialized IMU on board. What we're doing here is finding objects so that when we pick, or finding specific pixels in the image. So when I select a specific object, it can automatically look through images in front of and behind and reconcile and automatically pick that same object in those other images. I've got another example of what that will look like here. So what we do, or what our perception is we have the GS18I, we have an object that we want to capture, so we back up and we walk around that object. So we walk in a line where that object is offset to the right or the left. Then we go to the center of that image group and we pick that same pixel, and the system will automatically look at the images in front of, behind, and pick that same pixel and compute the point at the intersection. So this is very different than any technology that was out there previous using some type of visualization center, as those were static sensors put on control points and then had to be constrained. Because we can solve for the full 6 degrees of freedom. No, let me get my thing caught up here. I apologize. All right. So what that allows us to do is solve for the full 6 degrees of freedom in each image. So we can position X, Y, and Z, but then we can also place the pitch, even, roll to each one of these sensors, or each one of these images, so that we can compute the pixel and the intersection of all these and apply a code and the coordinate to that point. And this can all be done in the field. There are a lot of components that can be done in office software, and we will definitely be touching on that in a future webinar. But what we're going to focus on here is what we can get out of Captivate and the GS18I in the field in these following scenarios. We will show you a teaser at the end that kind of samples what we could get by incorporating the Infinity software as well. So what we're looking at here is there's a redesign of a roadway, whether they're just going to overlay it or they're going to completely enhance this area and maybe the intersection next to it. So this is something a lot of surveyors are very familiar with. We get a boundaries or a limits of our topo, and we can instantly go to the aerial photography here and identify 3 areas that are going to be challenging for GPS. 2 of those are challenging just because they're controlled environments, so they're gated off areas that we can't readily gain access to. And the other one is heavy canopy here that maybe we can't get the measurements from. Maybe these are big oak trees, maybe they're historic trees, and they're going to design around them, you know, shift the road, do whatever they need to do to make sure they preserve these large oak trees. So we'll cover each one of these challenging areas with the GS18I. I think the rest of it is pretty self-explanatory, how you would use RTK to measure the roadway, the crosswalks, and these other features here. So the first one is inside this electrical. You can see we have a bunch of meter boxes inside of this fenced-in area. This is an area where we could go in with, if we got access to it, we could go in with a GS18T and measure it. If you had a robot, you could set up on the outside and maybe get reflectorless measurements through the fence. You'd have to do some fine tuning there to make sure you didn't pick up the fence, but you could probably gain that, but you're going to be less efficient. You have to set control, you have to get different tools out. You have to do station setup, backsite, you have to something to check into. All these things take time in the field and slow you down. Maybe this is a long way away and that time will cause you to be there redundant days as opposed to being able to collect all this in a single site visit. All those things cost money to accomplish. So what we've done here is we've captured an image group like we showed in the previous animation. So we walked past the electrical area here outside the fence. And now we're going to go in and create points at these electrical chutes where they come out of the ground. So we simply go in, store it, calculate, give it a code, and take the measurement. Now that one happened to process everything automatically. Again, this one did too. It went to 5 images. We had 800ths of a QC value. So we're happy with that. On these next couple, we'll go in and we're going to pick as well. You can see that this is highly shadowed, so it's very dark, but we're able to see what we need to out of the image and we can start taking the measurement. In this case, we weren't able, the system wasn't able, probably because of the increased shadowing there, to automatically go pick. So we need to go and manually add some more vectors from different images. So that's all we do is at the bottom, we can scroll through our image group by going previous or next. We can get to those, we can zoom in on those images, and then we pick exactly where we want to create that point. And then you can see that we have a 2D quality of our intersection computed on the screen for us. And we can do this to as many images as we have until we get through the QC value that we are happy with. So there we had 4 points. Now we will pick one more of these, I believe. So I'm backing up to get to the center of my image group for the next electric feed that I want to grab. So this will collect an image when you're walking or creating an image group at about at one image every half a second. So there is a distance. You do want to be within 2 to 30 feet of the object you're trying to capture, and you want to digitize points inside of, like we are right here. So the great thing about this is still a GS18T with the imaging capability. So it's a GS18I, but it has all the capabilities of the GS18T, all the GNSS modernization along with the imaging sensor. So this is one tool that can do all your GNSS needs as a rover. So we'll go here, and you can see I'm moving down to get the image to where I can see the object that I want to create a point on. There I had to go quite far forward in the image group. Once I add that, we can create the point. Guess we're going to do one more here. I don't remember exactly how many I picked, but so again, that last one, you saw the lighting improved a lot, and it was able to automatically pick that point when it wasn't in the deep shadow. This is what it looked like. So we had shot outside the fence using RTK, and those are the points that we digitized inside of it. In the next area here, you can see that we have those large oak trees that we described in the outline of this project. So we have 5 of them, and we will measure those using the imaging. Again, this is an area where we have tools. You've been measuring this before. You've been using total stations, maybe in the right day at the right time. You can go in there with the GS18T and use the tilt functionality and the constellations in the right spot where you can kind of tilt it out and measure the base of that tree. But at the time when it's not, when the multipath is too high, do you want to stand around for 5 minutes to see if you can get that initialization? Is it worth it? Or if you have the GS18I, we can go through and capture an image group, go into that image group and measure what we need. So here we'll go in and we'll start picking these trees. Looking for something that's as most photo identifiable as I can on the trunk of a tree. We can use all of our coding and our attribute library to measure. I can see there that it still gives me a QC warning if I don't have the quality that I predetermined and set, so that's user definable. And then we can go in and we can add more measurements from more angles, basically, to get a better intersection of those than what was automatically calculated. So we add those, we get to a level that we accept, and then we move on to the next one. So we end up picking on all these, and we can create them. And again, this is all done in field with the field software in Captivate. So you can compute inverses, you can do anything you want to validate these points. You can create offsets, you can do other things in real time in the field. And all these will be shown in your Office download. So we have a couple more to go here. But you can see once you start developing and understand the workflow, it's very simple. It's very similar to any other measurements you take. Very nice that we can use the all of our coding and all of our attribute libraries stay the same, so we don't have to worry about any of that changing. We are very familiar to you.
Bob, how long did it take to capture the images and data for this particular survey? We might need to ask Ted. I know he's on the line.
No, so the images can be captured. The max is 1 minute. These are probably 30 or 40-second walks. You just literally walk past it. Like I said, it depends upon your speed of your walk and your distance. You normally walk at a normal pace. We get an image every half a second. So how long it took to walk from, or would take you to walk from one end to the other is all it takes. Like those short.
Each one of those fences took 15, 20 seconds at most, and I walked really slow. This tree line took about 35, 40 seconds. And again, I walked slow just to make sure that I had multiple images on there. So it was relatively fast in terms of just walking and collecting the images.
Yeah, and you'll notice that when you can see the perception when I hit next and previous there, how little the perception changes. That's because that next image has a lot of overlap and is very close to the one in front of it. That allows us, that's why sometimes you'll see we go 2 or 3 images right or left instead of just using the next image, is to get better geometry when we create this intersection of these different different views. So see there, I went like 4 images before I'm going to pick this next vector basically. Now I'm going to go the other way. Here we're at the very end of where I can see this object in that image group, but I can still drag it over. And it met our QC value, so it just stored the point. So there we've measured all 5 of those trees in there. We can go into our 3D viewer and we can see how they look in relation to the rest of our topo. So next, we're going to pick a couple of points inside of this gas substation. And each one of these are just a sample. We're pulling out certain amount of information, but you could go to each one of these image groups and we could just keep picking more and more points. But we just wanted to give you an example of what they look like when we create those. So again, we're looking at it inside of Leica Captivate. This is our field software, and we will go through and create a couple of points inside of this image group. So we go pick on the specific object, ask it to measure. Again, it gives us our 2D quality, and we can choose to either store and accept that, or we can add more vectors as need be. We'll go to the other edge of concrete here. Now we'll take a measurement on the pump and on the 90 turn there. So again, you see how easy it is to go in and select. We tell it to measure. This one did not auto calculate, so we'll go and select it in some more images manually. I mean, the nice thing is it's constantly giving us a QC value. So if there's something that doesn't meet your accuracy needs or your precision, you can choose not to take that measurement, and then you have to get another tool. But we're giving you all that knowledge in the field so you can make the choices that are right for you and your business. So here we're going to shoot the bend, zoom in. And we've got our measurements. So now in this next example, so that's everything there. We did the 3 areas. We did the fenced in area that would be hard to gain access to, covering the electrical. We did the gas substation, and we did the trees, all using the GS18I in those difficult areas. So now we'll go look at an example of maybe a parking lot Alta, where we can go, did you miss anything? Did I start or stop the measurement at the storm? So in this instance, we're going to zoom in here, and we don't pick up this inlet. You'll see in the line work that we have a radius on this curb and that it ends. This inlet is actually serving behind the curb as well for this planter area. But we don't show that. We show some tangent points. So somebody, it's 5 o'clock on Friday, they're trying to get out of there, nothing malicious, but they just didn't start or stop their curves. But the tangent lines, you wouldn't know that necessarily without seeing it in another way. We also have up here on the top, you can't see it exactly, but we'll show you in a second, where there's a manhole up there that is not inside of our measurements. So with that, we'll jump in, and I can go into my 3D viewer. We can zoom in to a couple areas, just doing some quality control here. And we can see we don't have that inlet inside of there. We see we have those tangent lines. That's not a curve through the back of curb and the face of curb and flow line like it should be. We can come over here. We're looking to see if we got that manhole behind the curb. Maybe I went to Google Earth or something else to QC this, and it kind of alerted me that I wanted to go double check that, and it's not here. So now if we have the image group captured, we can simply go into our GS imaging application, our measure inside of images, and we can select our image group. It opens up, and now we can go through those images to select that specific feature that was missed. So the first thing we're actually going to do here is just measure this edge of pavement. So we're just going to measure this as a check. We're going to compute a quick inverse. Again, I don't know exactly where he set down the tip of the pole, so I'm going to pick what I see on the screen as the PI for this edge of asphalt or the flag line, whatever you want to code it. We're going to call it a check of edge of pavement. We'll take the measurement here and we'll store that. Now we'll move up and we'll measure this inlet. So we zoom in, we select our point inside of the image that we want to create, and we change our code. And we'll measure that. So now we need to go to the other side of the parking lot that's in a different image group. So we go select that image group. I can see that's the back of curb, so I'm guessing there. Oh, look, there's my manhole. I can see my curb. So now I can go pick on the center. I'm going to change this to a manhole. We'll zoom in and fine tune that center pick. And we'll take a measurement. Okay, again, this didn't automatically go through and pick that, probably because of the angle and the lighting. It's all one color. So we'll go manually add a couple more vectors to this until we get the residuals that satisfy what we're doing here. So there we got down to 800s for our quality control of the intersection. So we're going to accept that. Now we'll go back into our 3D viewer and we can visualize this, and we'll do a check, because we'll check that edge of asphalt that I picked, or edge of pavement, versus the one that was shot with the RTK measurement. So image 007 was my measurement in the images, and the 620 there was the one measured with RTK. We can go into COGO and compute an inverse. And there I was able to get within 400s horizontally and 600s vertically of the same exact point. And again, I wasn't out there taking the measurement, so I don't know if it was actually on top of the concrete, if it was actually in the gap, or if he measured at the edge of the asphalt at the height. So I'm more than satisfied with that pick. Here we go in and zoom, and now I can see my manhole has been created behind my curb. All looks pretty good. So that is basically using the imaging inside of Captivate and some of the different scenarios that you can cover and overcome using this technology. And this is only the in-field portion. Now we'll play a quick video of some of the power that and some of the things you could do inside of the office in Infinity. So you can see this stockpile here. You can see the level of definition that we were able to zoom in and view this with. And now we're actually going to go in and rapidly just create a 10 over top of that. There, I have a 10. I can now contour that stockpile. I can turn my 10 off and just have a solid. And I can create a report on that all with just a few simple clicks inside of the Infinity software. So I did cut out a lot of other clipping and isolating to get down to that point cloud. But once you have that inside of Infinity, to create a volume report is just that simple. The next example we'll go through here is a site you're familiar with. You just saw it on the previous display of measuring the inlet and that manhole right there. And this is a point cloud, a dense point cloud generated from the images inside of Infinity. So we can see here our flag line, our flow line, our face of curb and back of curb are the four, the green, the blue, the magenta, and the aqua colors there. But we can see what this point cloud looks like. We can see the points that were measured for his striping as we pan down the face of curb to realize what can be done. A lot of people have asked, or in some instances, why is this different than flying it? And really, it's utilizing a lot of the same technology. The advantage is you can't fly a drone, or at least to my knowledge, you can't fly a drone and get good position at 6 or 8 feet to get these type of point cloud when you have these face of curves, when you have these oblique images in this area. So this is a great area where you could augment both data sets together and really clean that up and enhance the definition of features like that curb. You can also see here where we had those radiuses don't match up, and we have no curb behind the inlet there because it's draining the planter area as well. It's servicing a larger area. And that's all we have with that one. I think we'll move into questions and answers.
So Bob, real quick, you were just showing us Infinity. Does someone have to have the Infinity software in order to make use of the GS18I data, or is there another way that they can make use of it in their workflow?
No, absolutely not. And that was what we were showing in those previous examples, was what we could do with the eye and the imaging inside of Captivate. So there's a stopping point where you can deliver up to that, and that's fine. Or you can continue to grow and you can just pick points similar, but maybe it's a little bit faster to do it inside of Infinity, because maybe it's just more relaxing because you're inside the office, you have a bigger, nicer monitor, you have a nicer chair than the front seat of your truck. So maybe you want the points and images, or you can have the point clouds from images, which we were showing at that very last one with the stockpile or the back of curb. So all of those are points where you can choose what level or what service you need, or what fits your workflow, or what deliverable your customers are asking for. Because that's what it's really about, is the deliverable that you are delivering to your customer. So if they are not interested in the point cloud, doesn't have value to them, then maybe it's just about you doing the job faster or better, not having to wait on other people to gain access to those enclosed environments so that you can get the measurements to satisfy the need. Or maybe there's another customer base, or it allows you to grow later and add those point clouds from images in Infinity so that you can start doing stockpile work or other things for a different customer base potentially.
Okay, that makes sense. Now we do have a number of questions that have come in from the audience. We'll get to those in just a minute, but I was wondering if you could address briefly, we've gone through a lot of different capabilities today. We started off by defining some terms and highlighting that some of the capabilities are actually available in some of the other GNSS solutions, like the GS16 and the GS18T. So for someone who's on the line today and they recognize that maybe it's time to upgrade their GNSS to take advantage of the latest field capabilities, how can they go about weighing wants versus needs? I mean, everyone wants the latest and greatest, right? But maybe that doesn't fit within their budget. Or how can they make that evaluation?
Great point, and it's really for them in their business. We will help guide them, and it's a lot about what they do. And if you do a lot of topo work, if you do a lot of staking of houses, then you have to absolutely weigh the value of the tilt compensated rover. Whether it's the value because you're doing it faster, whether it's the value because you're playing in roads, and those are very dangerous environments. So by giving your crews a tilt compensating rover, they can maintain a better situational awareness. They have a better grasp of where that traffic is. It's daunting out there to stand and measure a center line when there's a car coming at you, and the person may or may not be driving with their knee and texting, and they look like they're going straight now, and you have to look down and focus on this bubble to get an accurate measurement, whether it's a section corner or whether it's just striping. You need to be close to plumb when you take those measurements. So you have to take the focus off of that. With a tilt compensating rover, you don't have to do it. If you are growing, like I said, if you're busy and you're doing a lot of remotes, maybe you're going out to sites multiple days and you could use an imaging rover to reduce that to a single visit. Maybe you could leverage office staff because you have more of them. Maybe they're easier to hire drafters than it is to get field personnel or whatever. So now you can create a better synergy between the field and the office and take some of the field time and shorten it by adding it to the office and not making it more complicated. So these are all things that your local sales rep can really help you dive in. If you're just doing geodatic survey work, probably a GS16. If you're doing a lot of static work in rural areas, probably a GS16 will fully satisfy your needs and let you take advantage of a lot of the GNSS stuff, the satellite constellations, the smart check. You can utilize all that, but maybe the tilt compensating rover for measuring and redoing monumentation doesn't bring a lot of value to that workflow. So then if that is your core business, maybe you're a county surveyor and that's what you do, then maybe the GS16 is all you need in your toolbox.
Yeah, it's kind of interesting. We're pretty much in a situation where technology for surveyors like GNSS is, we almost have to view that as like consumer technology, where you're not satisfied with a cell phone that you've had for 5 or 8 years. You know, you need to upgrade. You know that it's new, it's better, and things are just changing so fast that it's definitely worth looking at what the possibilities are if you have better capabilities in the field, right?
Exactly. The better, and what is it costing you not to have it is really the question. And I also encourage people to think about, if I say I'm buying one next year, what I'm saying is I'm giving up the advantages that it would give my company for 1 year. Now, everybody knows that there's a CapEx limit. We have salaries, we have in Leica and all, nobody that runs a corporation or a business is any different in that. And there's always limited resources, and that's always going to be the balance. But if you can generate more revenue, those are the things you need to probably pay the most attention to when you're making these choices.
Excellent considerations. Now, we did have some questions about the point cloud generated by the imagery from the GS18I, and specifically the accuracy of that point cloud. Can you address that? What should people be looking for in that level of accuracy?
So it should be in that 3 to 5 centimeter range. Again, you have to remember that your distance to your object, we need to be capturing that that point cloud or those image groups between 2 and 10 meters, so between 6 and 30 feet. But along with that, we have to be realistic of what we want to get out of it. So this is not LiDAR data. This is not a point cloud picked up by a scanner or any such sensor. This is more closely related to a point cloud generated from a drone. The difference is we can get better obliques potentially than you can with a lot of drone data, so they can augment one another. Or maybe an example of like that curb we were looking at, that building is co-located with an airport. So getting a drone to legally operate in that environment would be difficult, if not impossible. Plus the other challenges to your business. Same with the stockpile that we picked up. That's a great stockpile. I don't think that I could topo that anywhere close to that accurate with that much definition given a big disparity in time, right? So there would be a huge gap in the efficiency of collecting that data. And again, if I need an RTK system on site to put that drone data into a real world coordinate system, then maybe I don't need a drone. Maybe I can just do this with the GS18I because I already need that sensor to put ground points on there to position my drone, where I don't need that if I'm using the GS18I. So maybe in a lot of those cases, you can either use them together, or maybe it overcomes the need for another tool in your toolbox.
Sure. Good points to think about. Now, someone else wanted to know if you can edit a saved point by adding more images later or choosing other images that have not already been used.
So you can combine image groups inside of Infinity. So I can go in there. I really can't edit that single point, but I can just go recreate a new point at that by adding more information. So if I took 3 vectors, or it automatically solved with 3, but maybe I went around a corner. And if you go around a corner, you can provide, just like doing an intersection, I can provide a completely different angle. So that's going to give me a higher strength of figure when I do my intersection there. You can do that later in the office and just delete the first point and create a new point with more and different information very easily.
Okay, excellent. Looks like our guys behind the scenes have been doing a really good job of keeping up the questions. Tim, are you seeing anything else that we should bring up in this portion of our discussion?
Yes, Christy, just a couple of things. You covered most of them. You did a great job today, so you made it easier on me trying to keep track of this list. Thank you. I think it's worth, because this came up a couple of times, just for acquiring the data with the imaging GNSS, what is the optimum range to achieve the fairly precise results, as far as distance from your subject matter?
The maximum range is 30 feet. The minimum range is 6 feet. Optimal, it really depends upon what level of detail and what you're trying to accomplish. If you just want a broad overview to help your draftsperson maybe see where somebody had shot and didn't put curves in those backs of curb going to the inlet, then I can be quite a bit further away and help realize that, right? However, if I want to pick a lot of points, or if I want to create that point cloud, then the more refined the point cloud, then the closer you want to be. So you would want to be maybe 9 or 10 feet away to get optimal with very detailed point cloud. If you don't need that level of detail, so if you're trying to just get maybe dimensions for entrances. So one of the things that is not just the accuracy of the points or the point cloud, but it's the relative accuracy once I start dimensioning things with inside of there. So if I start measuring doorway widths, if I start measuring, those things are unbelievably accurate in relation to themselves for using those dimensions. So then probably around 15 to 20 feet is, if you could get that, is probably ideal, kind of the middle ground.
Okay, thank you. Let's see, I think Christy actually covered the bulk of the questions. We had a lot of really good questions. There's several of you that I've got a note to follow up with because they were a little bit off topic for this session. And then some of these in terms of what about generating these point clouds? How do they mesh with the UAV data?
If you're using ground control that was set with the GPS, everything's in the same coordinate reference frames, they will mesh extremely well. We've seen instances where we've, don't have examples here, but where we've flown over buildings and obviously the oblique building faces were left very sparse on data from the drone. And then we've augmented that with GS18I data and they come together extremely well.
Well, Infinity is a great tool to do that as well. And I know we're going to, in our next webinar, we'll be doing a deep dive into the Infinity workflows to really show the power of using those tools with this data. So if that is all of the questions, I think we will go ahead and conclude today's session. As you exit the webinar, I would like to ask you to take a moment to answer a brief survey that should pop up on your screen. And I would encourage you, if you're looking for more ways to optimize your field and office surveying workflows, visit pure-surveying.com/insights. There are a lot of really great articles and tips that you can find on that website. We do appreciate your time, and we hope that you found this webinar to be a valuable experience. Thank you very much.